Hello everyone. Welcome to Knowledge Base. If you're new here, don't forget to hit the subscribe button and click the bell icon to stay updated on all my programming tutorials. In today's video, we're going to explore one of the most important concepts in Java: interfaces. We'll understand what interfaces are, how they are different from classes, and where they are used. We'll also look at some real-world examples and code demonstrations to make things crystal clear. So let's dive in. An interface in Java is basically a blueprint of a class. Contains method signatures but no method bodies. That means it tells what needs to be done but not how. This feature makes interfaces extremely powerful for abstraction and multiple inheritance. Let's look at some key characteristics. Interfaces can only contain abstract methods, though from Java 8 onward, they can also have default and static methods. All variables in an interface are public, static, and final by default. All methods are public and abstract by default. And yes, interfaces cannot be instantiated. So why should you use interfaces? Interfaces help you achieve 100% abstraction, implement multiple inheritance, provide a common structure or contract for unrelated classes, write loosely coupled and easily testable code. Now comes the most common question. What's the difference between a class and an interface? Let's compare them side by side. The major takeaway here is, a class can have both method definitions and variables of any type. But an interface is more like a strict contract. You define the structure and let classes implement the details. Let's see how to implement an interface in code. As you can see, the circle class implements the drawable interface and provides the body of the draw method. In Java, a class can implement multiple interfaces. This is how we achieve multiple inheritance. Both methods, print and show, are defined in the class A. From Java 8, interfaces can also have default and static methods. Default methods can be overridden. Static methods belong to the interface and can't be overridden. Java 9 introduced private methods inside interfaces. These help reduce code duplication inside default methods. The private method log is used by the default method display internally. Now let's do a quick comparison between interfaces and abstract classes. Remember, use abstract classes when there's some common functionality to share. Use interfaces when you only need to define structure. A functional interface contains exactly one abstract method. These are used with lambda expressions introduced in Java 8. You'll commonly see these in functional programming and with Java streams. Now that we've seen what interfaces are and how they're used, let's talk about the advantages of using them in real-world Java applications. First, interfaces help us achieve abstraction and loose coupling. With interfaces, we define what should be done, not how it's done. This means the implementation details are hidden, and your code becomes more flexible. One class can easily be replaced by another as long as both implement the same interface. This leads to loose coupling between components, which is a core principle of good software design. Second, interfaces allow multiple inheritance. Java doesn't support multiple inheritance with classes because of the diamond problem, but it does allow a class to implement multiple interfaces. This enables developers to mix and match behavior from different sources without causing conflicts. Third, using interfaces improves testability and modularity. By programming to interfaces rather than concrete classes, you can easily substitute mock implementations during testing. This makes unit testing simpler and your application more modular, because individual components can evolve independently as long as they respect the interface. And finally, interfaces are essential in API design and plugin architecture. Most modern frameworks and APIs rely heavily on interfaces. For example, in JDBC, you use the connection, statement, and result set interfaces, not their concrete implementations. This allows for greater flexibility and extensibility. In plugin architectures, interfaces define extension points so that new components can be added without modifying the core system. So, overall, interfaces are not just a feature of the language. They are a powerful design tool that helps build maintainable, scalable, and robust applications. Some real-time Java interfaces you may have heard of: Runnable, Comparable, Clonable, Serializable. These are used in threading, sorting, object cloning, and object serialization respectively. Let's implement all the interface concepts we have discussed so far practically one by one. Let's quickly summarize what we've learned. Interfaces are blueprints that help us achieve abstraction. They support multiple inheritance. From Java 8 onward, they can have default, static, and even private methods. Widely used in frameworks, libraries, and real-world APIs. Thanks for watching. If this video helped you understand interfaces in Java, give it a thumbs up and don't forget to subscribe to Knowledge Base for more programming tutorials. Got questions? Drop them in the comments below. See you in the next video. Subscribe to our channel to increase your knowledge with the Knowledge Base. Thank you.